one application in this direction, that this technique also works to deform equivalence in characteristic 0. So if you have y lift deformation, then there is a unique, let me put a big asterisk here, I will write the fine print afterward. So there is a unique deformation over R and an object, a perfect complex P in dB curly x y, specializing to, and the fine print is under certain condition that will be clear when we develop the thing. So like it's the same thing as yesterday. Like we want we transform our thing in a deformation. So Fourier-Mukai partial characteristic P, if you know the resulting characteristic 0 with the complex number, to study them is just a deformation problem. And these provide a solution. These provide the solution of the deformation problem. Furthermore, P eta in dB x eta times y eta induces an equivalence. So these provide the solution of the deformation problem, but as last time, like the solution we had at a certain condition, we had to check the sunline bundle lifted and so on. And this is analogous. Like in order to use it, we have to check some conditions. So in order to apply it.
Is it just for uniqueness or existence?
No, it's for everything. So well, it's if there is, then if you prove that there is, and you have it induces an isomorphism of deformation spaces, and then it's unique. But it's more for the there is that we like in order to. Okay, so let's start from the back and assume that we have such a thing. Let's show that this is indeed an equivalence. And so this is the first part of today, being an equivalence is an open property. Okay, so let's formalize this. If you have an object in Y, perfect, such that PK is induces an equivalence, then so does I will try to be constant with the font. It's a bit obvious for me, so if it's confusing, stop me. If I use the wrong font for P, and then in the afterward there will be a D that is curly when it's a stack and not when it's not a stack. So please tell me something. Okay, so this is all based on the composition formula for integral transform. That is all the mean. I 1981. And so this, if you have, let's remind you, if you have P, let's do it curly already. In DB S R Y and Q in DB Y R Z. And so if you have the integral transform with kernel P composed with the integral transform with kernel Q is isomorphic to the integral transform with kernel P star Q, where P star Q, P star Q is, okay, so we start from something from xy and something in yz, and we want to get something in xz. So we push forward. X, Y, Y, Z. So this is a composition formula of Fourier-Mukai functor or integral transform or whatever you want to call them. Okay, so now thanks to this and the Mukai work, it's one of the reasons why we like to think of equivalence as integral transform is that it's easy to give formula for adjoint. So the adjoint, the right adjoint of phi p is given by phi PL, where PL, no, it's the right adjoint, so it's PR, where PR is the dual of P composed with omega y over r shifted by the dimension of y over r. And then we got, let me use the blackboard effect. So we have the left adjoint is given by the integral transform with kernel PL. So it's phi PL, where L is dual of P, and so omega x over r is x over r. Okay, so now we have, since they are adjoint, we have morphism, natural morphism, is a functor morphism from phi p composed phi pr into the identity factor, and phi eta L from phi PL composite. I hope I didn't mix the order of Adjoint, but we have morphism like that. And you know, how can I read equivalence from this? So phi pi, like the integral transform with kernel P is a, well, a functor is an equivalence if and only if these are isomorphic.
Do we assume the elliptic is actually smooth map or something?
What?
Like do we?
Yes.
Ah.
So equivalence if and only if I would say these are isomorphisms. And okay, but now the identity is the integral transform with kernel. So this was the identity on y, and this is the integral transform with kernel of x. And functorial morphisms between integral transform induce morphism of the kernel. And so these induce morphisms that I call with the same name, eta r problems, from P I used PR over P in delta O of y, and eta L from PL, P over PL over O of L. And so again, this is an equivalence if and only if these are isomorphisms. But being an isomorphism is an open property. So if these are isomorphisms on the closed fiber, then they are isomorphisms in the general. Okay, so we solve the equivalence. So if we find, given a deformation of y, find the deformation of x, such that the kernel lift, then the lift will induce an equivalence on the genetic fiber. Then now we have to provide the deformation of x, which is, we say, compatible with, the given deformation or lift of y that we have. Okay, so the crucial idea is to think of Fourier-Mukai partner as moduli spaces of perfect complex. And if you are hoping to see Bridge stability condition in this talk, I will crush this hope right now because they don't use stability condition, like Bridge stability condition, to consider this, to create this moduli space. Is entirely a stacky thing. Okay, so let's explain. I will wave a little bit my hands and to give you an idea for where I aim to, and then I will give you the detail. Because otherwise, I think it's easy to lose yourself in this. So what we have to prove is that we have to prove we will need an equivalence from dbx to dby induces an open immersion of x in some dy, where dy is some moduli space of perfect complexes. And first condition that was in the fine print, if for some reason that we have in our situation, x goes inside dy, the smooth locus of dy, then for any a Artinian W algebras, observation R algebras are W algebras. So this is why we can take W is the ring of bit vectors. So that is why we can take W even if it was not W there. Then for any and any YA over that A deformation of X of Y to A. And here you can substitute, in whatever I do, you can substitute W with the base field. So if you are in the complex, if you think that, I don't know, you are in, you know something worked for some special complex K3 surface, and you want to prove it for all, like this works in the same. So, but instead of W algebra, there you will have real, like the usual deformation of K3. So you can take K algebra here. It's, so we get well, So we deform Y to spec A. This is a modular space, and modular space are functors, so they are made to deform when you deform Y. So this is why they are created in some sense. So what we get, so we have dya deform and to spec A. But X is inside the smooth locus, so we can cook up XA. So this is the unique open subscheme of dya supported on X.
I can ask about the first condition. So X is smooth projective, right? Yeah, X is smooth projective, right? So when it embeds an open somewhere else, it will fail to be like an isomorphism somewhere, like non-separated. Like
yes, it's so.
What's the component of that stack?
The thing that, so the reason that how the morphisms go, like basically, set theoretically to a point of X here, you associate P, Px, and then so you have to look at the tangent in that point to see if it's so you have to look at the obstruction theory of perfect complex, because if that does not vanish, then you don't know. So yeah, so this is the way the way in which I understand this is that you have to check the obstruction theory of perfect complex to make sure that you are in this situation. But yeah, so it's then it gets too stacky for me. So okay. So this is a unique open substack of dya supported on X. And okay, so now we have these, and the second thing that we have to prove is that PA lifts to XA times A YA. So this is so let me circle. So this is something that need to be controlled in some way, and this PA lift to, and then we have to prove the open immersion, and then we have to prove that that with this particular deformation, then the kernel lift. And then now we have the conclusion. If we are able to survive this part, then we can
How big is the Moduli space also?
I have no idea, but I think it's a piece of what the Max. Okay, I'm going to have a spoiler. So it's a piece of what Max called the mother of all moduli space. So
It's like algebraics have already derived.
it's R-team.
So it's not derived.
Yeah, no, it's
It's a finite type or not?
yes. But yeah, so I'm going to, I will tell you exactly what dy is, and then you will see that with this spoiler I ruined a little piece of well, let's I was planning a joke, but now it's kind of ruined. You will know why I denote something in a certain way. Okay, so yes, so where I am. Oh, okay. So now we are here. So then we start with y over r, and then from these we can get yn over rn, which is r over m to the n plus 1. This is an Artinian W algebra, so we get xn over rn and pn over bbxn rn. And so, you see, since everything is infinitesimally, everything works. The problem is now is algebraization.
And where do you get this from? Where do you get xn?
So I start, well, from this, no? Because to any infinite, so
You assume 1 and 2 are
so I have this, and I get this. Now this is Artinian, and so by this, if we survive this part, then we get this. And when we get this, and we get this and this. Now the problem is algebraization. So first, this gives us a formal scheme, a priori, not an algebraic scheme. And this Pn will give an object, like a formal object on the formal scheme. And so now the problem is algebraization. But we are lucky, because if, for some reason, we know that xn are n algebraic, so for some reason we know that xn are n algebraic, then by Grothendieck algebraization theorem for perfect complex, which is not by Grothendieck, we have an object P, a perfect object, such that P is isomorphic to Pn. And so it may seem we get algebraization for free. I will not say that this paper is for free, like it's Moduli of complex over a perfect morphism, and it's yeah. I think it starts with let X be a tuple. And so yeah, yes. No, so this is it's I have not constructed that yet. So it will be because this is that like object in here have that property.
So for the one you get further.
Yes, yeah. So here so it's from the construction. It will be because everything will be universally gluable. So yeah. Okay. So and so here we have another thing that require checking if we want to use this technique. Okay, so again, so this is the outline, and we have to see one, and did I put two? Well, probably I already erased it. Well, okay, yes, yeah, here. Yeah. So we have to do 1 and 2.
Sorry, I remember the original transitive algebraization, you need some line bound dots.
Yes, and here you don't. This is the thing, is for free. Like a part of me wanted to say, well, everything, like in math and nothing is for free, because well, you have a formal list, you want algebraization, you have to lift a line bundle, and probably you have to pay with instead of bit vector, go to the ramified extension. But in here, it is for free. Like if these algebras, everything algebras. The payment of having this paper, that you still pay something. Like if you really want to understand it, then you still pay something. But it is free. So it's I think it's magic things or sheer luck that otherwise nothing will work. So if we had to also to algebraize, nothing will work. But P algebra. Okay, so you can mix the order of my. Oh, okay, so here we are, and so now we go and explain the open immersion. And now we really get stuck in. So if we have Z to S morphism of finite present. I have to say what S finite presentation. And P to S, so of schemes. That's schemes. And then we have T of S, so TS is an S scheme. Then we have a category, we define a category hybrid in groupoid. In this way. Yes, the inertia of this blackboard is. I'm always afraid that I will push the one too high, and then I will not be able to. My Mediterranean hate will not allow me to reach it anymore. So we go from S schemes to set, and to T, I And so this is also a reference to my postdoc that he had to speak about the mother of all moduli space in the introduction of his thesis. And he used a notation that basically it was a Finnish word for mother at the end. So this is.
Was that Thomas?
Yes, it was Thomas. How many Finnish people you know? Okay, so.
He is the only one, in fact.
Yeah. There are not many Finnish.
There's not.
It's a not densely it's a sparsely populated country, and for some reason there is no one doing algebraic geometry in Finland. So, okay, so we have. So what is mom t? Mom t are e in the derived category of all the modules satisfying 1 and 2. So 1 is E are relatively perfect. Meaning that if you have U to T quasi-compact, and so you have this diagram here. You have Z that goes to S, and then you have T, and here you have ZT, and then you have U, and you have ZU, and you have the pullback of E is bounded. 2, E is universally gluable. And which means that if S is in S, then xi of ES, let's for once use ES 0, and I is negative. And then theorem by Lieblich.
Can I ask about this parameter? So on the left there's T, and on the right there's Z, but the notation doesn't include any Z. Like, how to say it? Like, so why is there Z on the right and T on the left?
Oh, it's the T. Sorry. Yeah. Thank you.
But this mom kind of depends on Z.
Yes. Yes.
Z is fixed.
Well, yes, it's because it's mom of that. It's the mother of all modular space on Z. So, like, probably, yeah. Z is the other parent. Okay, so Lieblich say that mom gives an Artin stack locally of finite representation denoted by curly V, or if S is not clear, VS. And this is really what he calls the mother of all modular space.
Technically, for a stack, you need to go into group orders, not sets, right? So why do you go into sets? Like you said, set.
Sets. Oh, well, it's a category order in group order.
But if you go to sets, it's like a sheet.
So, yeah. I'm pretty sure that this is what, well, maybe, yeah, but what do you? Group boy, yes. Yes, probably, yeah. Okay. So this is the matter of moduli space. And here, if you're interested in bridge stability condition, you should love the matter of all moduli space, because this is the first step in proving that Bridgeland moduli space are nice stack. Like it's because you realize as a substack of these, and then so with Abramovich, Polishuk, and Soda, and another Arthur, and other people, then you get that Bridgeland moduli space are decent stacks.
This is this old paper of Lieblich, right?
Yes. 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 Yeah, these are all. It's in some way they were able to pull together all these really abstract results of maths and get a tool that is extremely useful. Okay, so a remark towards using your memory in case like I plan to prove things, but I'm not sure I will have time. In case I will do it at the end of next lecture. So keep in mind one thing that it will be useful at that point. So if S is of finite type over a field, then so for example, as spec A Artinian, then it's 1 and 2 can be checked. On one close point. Okay, so definition A. So we say that E is simple if the natural morphism of algebraic space from GM to out E is an isomorph. And we have, so here we have DS contains the substack of simple object, and this as an open subset, and this is a better stack because it has a coarse modular space that I will denote as Roman D S, and this map is a GM-GERB. If you don't know what GM-GERB are, like, they are nice stack, much better than Artin stack of locally finite representation. And in particular, we have that this is an algebraic stack.
sorry, in every space or something.
This.
I mean, this is every that.
So this is an algebraic sum. It's a gemger. So. And okay, so if we have x and y smooth projective, and over things, we can denote, we have FF. I'm using the same notation as in the Martin and Max and Martin paper. It stays for fully faithful, and the reason is why it will be clear. So P in the derived category of x times y, such that the induced integral transform is fully faithful. And we have a lemma that this is one of the things that I wanted to prove, but I will not. At least I wanted to give a sketch of the proof, but I will not. So P in FF, we have that one P is an element of, I think there should be a S here. X, and two, P induces, well, let's clear here. Morphism mu P from X to S curly D Y K, which is a verb on S Roman D Y K, so that this is an open inversion. Well, like it's theoretically, you see how this map goes. Like a P, an object in here, like you have a map to Y, and so this is a scheme over Y, and you and so P, an object in here, actually it's a perfect. Like you have to check that this is universally. Like you have to check universally gluable and. The other one, what was relatively perfect, but and then you get the morphism, and then you have to check the isomorphism of the tangent boundary. So if I have time, I will prove this lemma at the end of tomorrow. So as a corollary of this thing, we get a fully faithful functor of group points. Yes?
It is like open inversion of algebraic space.
Yes. Yes.
So isomorphism is a derived one, or?
No, they are not derived. So yeah, at least there is not an ounce of evident derived algebraic geometry in Max and Martin paper. Otherwise, I don't think I will ever have even read the introduction, which would mean that I would have many less paper in my CV. so yeah. Okay, so as a corollary, we get a fully faithful functor, of groupoids between F and something that I denote like that. This is the set of map from X to the curly one. Y such that, so here we have the non-curly one. Open immersion. So as a corollary of this lemma, we get this fully fatal functor of groupoid. So basically, for any, a perfect complex induce immersion of modular space. Well, induce an open immersion here. And this is then what we go back to the lifting problem. So suppose mu p x goes inside S d y smooth. So again, so we are working under these assumptions. So this x goes into the smooth locus here. Then we have ya, a deformation. So in that ya, ya in that ya. And then what we do is, well, we have the curly y, that leads to so dy. So these are the course modular space, and we can get a gerb, like we can get a substack in here. So there is a course modular space, and it's A, and this is a gerb. And XA goes into here. And in addition, so in some way naturally you get an object PA here on like a lift. So because you see you get an open immersion which spits you a PA, but then if you are lacking careful, in which it's happening in the application, then curly PA induces so curly PA is in here, the YA XA, and induces PA in the YA XA, specializing and so here I want to make some remark. I lost the orange here. So I want to make some remarks. So here you have to be careful because so these are gerbs. So a priori, what you get, you could get a twisted sheaf here. But in the original, so in the the original paper, if I keep the original paper by Martin and Max, they have to check that what they get is actually a sheaf. Or actually, what they do, they find an invertible twisted sheaf and they make it into a sheaf. And another thing that I want to tell you is that these also work for twisted derived category. So the same argument more or less works for twisted derived equivalence. More or less the same. The thing is, instead of y, you already consider a gerb over y. So if you ask Max, the right point of view on twisted sheaf is GM gerbs. And then it's with that point of view, basically, if you are able to and willing to work with stack instead of projective variety, then instead of starting with y smooth projective, you take a y smooth projective and a GM gerb over y, and you do the same, the exact same argument more or less, and you end up with a twisted sheaf that specialized to your original twisted sheaf. So, and this is important because it's the only application I have in mind of this thing in characteristic 0 is on twisted sheaves. And okay, so I think I will stop here because otherwise I will take too much. So next time I will speak about obstruction theory for perfect complex. That it's one of the technical obstacles in using this technique, that you have to do some checking there. And then I will start with the application, and the first one I will speak of the original paper of Martin and Max, because in there it is clear how that you might have to work with the algebraization because you have to check that your x, here it's just infinitesimal, so you have to check that at least xn algebraize. And then I will go into my paper with Max and Katrina that we do by Lieblich and Enrique suffix, that are easier on the deformation point of view because the tangent like H2 of OX is 0. But then we could not use we could not use the statement for obstruction theory of perfect complex was just in OX trivial canonical bundle, and so we could not use that, and we had to find a way around it. So this is the plan for tomorrow, and if I am too quick, then I will torment you with the proof of the lemma. Okay.